when you're looking at fractions, you would like to know if two fractions are equal or not. And that's really one thing that's really useful to be able to compare, because you know, if I give you 2 jelly beans and I give you 2 pencils, it's pretty easy for you to tell me if you have the same number of jelly beans as pencils. You just count them. You have 2 of each, so yeah, you have the same number. But if I give you a fraction, it can be a little bit more challenging depending on what you have. So if I tell you, you know, I have, you know, 2/3 of a piece of 2/3 of a pizza, let's say, 2 slices out of 3 whole pieces, right? And I tell you that you have 2/3 of a candy bar, which is if you cut the candy bar into 3 pieces and I have 2 pieces, then speaking in terms of fractions, you would say these 2 fractions are equal, because basically out of 3 pieces, you cut each thing into three pieces, and I have in my hand 2 of those 3 pieces here, and I have 2 of those 3 pieces in my other hand. So yeah, I have the same amount of pizza relative to fractions, the same amount of pizza as I do candy bar, because I divided them both up into 3 pieces, and I have 2 pieces of each of those things after I divided them up. All right, now the problem becomes a little bit trickier if I ask you something like this. Is 1/2 equal to 5/10? And that becomes a little bit trickier, especially when you first start dealing with fractions, because you don't have enough experience to know what 1/2 and what 5/10 really look like, and if those things are related to each other, but you know that they might be equal, you just don't really know exactly how to do it. Well, the bulletproof way to do it would be to draw a picture. I mean, you could do that. So let's say for 1/2, we draw a picture. So I cut it into 2 pieces, and I take half of it away. So that's what 1/2 looks like. Now, if I take the same exact pizza and divide it into 10 pieces, well, there's that piece. Those 2 pieces. Okay, how many pieces do I have now? I've got 1, 2, 3, 4, 5, 6. Let's count the pieces now. 1, 2, 3, 4, 5, 6, 7, 8. Let me go ahead and draw another slice down here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 slices of pizza. You have to use your imagination a little bit that these are equal slices. Now, when I'm drawing on the board, it's a little difficult to make them perfectly equal. But even still, if you use your imagination, then I think you can agree that if I cut it into 10 pieces, let's look at what happens if I have 5 of those pieces. Well, here's 1 piece, here's 2 pieces, here's 3 pieces, here's 4 pieces, here's 5 pieces. So this is what it looks like to have 5/10 of a pizza right here. See the blue? It's basically the same as half of this pizza. So yes, they look completely different. 5/10 looks totally different than 1/2, but I've just shown you by drawing that they're actually exactly equal to each other. And that's the deal with fractions that confuse students at first, because they look totally different, so you don't really know which one's bigger, which one's smaller, or if they're even equal to each other. But you're asked to figure that stuff out on your homework and your test all the time, because you need to know how to do that stuff. Now, drawing a picture, it really is always going to work. You could do that. However, if you're drawing pictures all the time, you're going to be very slow. Plus, what if I give you a fraction like, 24 out of 36? So you have to draw 36 slices of pizza and try to shade 24 pieces. I mean, it's just not going to work. So there needs to be a better way. We've said before, if the denominator is the same, in other words, if I've cut the pizza in the same number of slices, it's easy to see if they're equal because the top numbers will be equal. What we need to do is figure out a way to basically change one or both of these fractions to give me the same denominator, and then I can make the comparison very easily. So here's how we're going to do that. And I'm going to teach you, and there's different ways to do this, okay? There's different ways to do this, but what I'm going to teach you to do is the following. Rewrite your fraction over here. So let's say, let me draw a little squiggly line here. Let's say I've got my 1/2 here, and I've got my 5/10 here. The number one rule of fractions, okay, is I can multiply or divide any number I want into this fraction, as long as I do it the same to the top and the bottom of the fraction at the same time. You got to think of fractions as a seesaw. Think of this as a seesaw. If I have a seesaw here, out in front of me, and I've got 2 kids balanced on the seesaw, if I go up and put a bag of sand on this side of the seesaw, it's okay as long as I put the same weight of sand on the other side, then the seesaw remains balanced. If I put a truck on this side and I go and put a truck on that side, everything continues to be balanced. But if I just put something on one side by itself, well then the seesaw flips over. So same is true with fractions. I can multiply or divide the top and the bottom of this fraction by any number I want. But I have to do it to the top and the bottom. I have to do it to the top and to the bottom at the same time. Then the fraction remains equivalent, basically the same thing. So let me just show you by example how to do this without drawing a picture, how to figure out if these two things are equal. What if I multiply this fraction, what if I multiply the denominator by 5 and the top by 5? I told you I can multiply or divide this fraction by anything I want as long as I do it to the top and to the bottom. So if I do this, 1 times 5 is 5, and 2 times 5 is 10. So I have shown you that basically if I do this to this fraction, I get 5/10, which is exactly the same thing as the other fraction I'm comparing it with. So I have proven that these two fractions are actually equivalent to each other without actually drawing a picture. You wouldn't even need to draw this picture. All you need to do is figure out how to multiply one or both. Sometimes you need to do it to both of the fractions, but a lot of times you can just pick one of the fractions, multiply it by something to try to get to see if these things are equivalent. So what you're trying to do here is you're trying to look at the fraction and you're trying to say, okay, gee, here I have a denominator of 2. Here I have a denominator of 10. I want to try to multiply this fraction by something so that I'll have a denominator of 10. Well, 2 times 5 is 10, so I'll do that. But if I do it to the bottom, I have to do it to the top. So 1 times 5 is there also. Then I get my new fraction. This fraction, 5/10, I've just shown you if you draw it is exactly the same thing as 1/2, and so that's what makes sense there. So we've drawn a picture. I've shown you how that is true. And now for the rest of these problems, we're not going to draw any pictures. We're just going to do the math. So let's say we have a fraction 2/3, and we have a fraction 8/12. And I would like to find out if these two fractions are equal. Now, I could draw this fraction, cut it into 3 pieces and shade it, take 2 of the pieces away. I could cut this pizza into 12 pieces and take 8 of them away, and I could look at what I've shaded, but I don't want to do that. I want to try to figure it out by, by math. So the way I do that is I think I can work with this fraction because if I multiply 3 times 4, I'm going to get 12. You want to get the same denominator. So I'm going to do that. So 3, and I'm going to multiply the bottom times 4. But if I do it to the bottom, I have to do it to the top, right? So 2 times 4 is 8. 3 times 4 is 12. And looky here, 8/12. That's exactly the same thing as the other fraction I was comparing it against. So yes, they are equal. Those two fractions are equal. You would never really guess that they're equal by looking here, but I promise you, if you draw these fractions and you shade them, and you look at what you shaded, they're going to be the same amount of pizza in both cases, just represented a little bit differently, right? Okay, what you're doing here, I'm giving you a little bit of an advanced preview of what you're really doing here to compare these fractions is you're finding a common denominator. And a lot of kids, a lot of students, doesn't matter if you're a kid or not, a lot of students have problems with finding common denominator. People don't understand, why do you do it? Why do you need to find a common denominator? Well, this is the reason why, because you need to put these fractions on equal footing. If you see that you divide each pizza into 12 pieces by changing this one so that it's out of 12 pieces, then it's easy to figure out if they're equal because in each case I took 8 slices out of 12. Here it's harder to see because I only had 3 slices to begin with, so it's difficult for me to visualize it. But if I can transform one of those fractions so that I have the same denominator, the bottom number, in both cases, then it's easy to compare the numerators to figure out which one's bigger, which one's smaller. Maybe they're equal. All right?